Hello and welcome to this video. My name's Andrew from GP3D. So recently I've started a GP3D membership. So trying to bring together some of the community to talk about the design of RC cars and sort of evolution and 3D printing and all the sort of aspects that relate to that part of our hobby. So I'm hoping that's going to really connect with a lot of people in terms of the design and evolution of our cars, as well as just sort of building and racing them. Part of that GP3D Membership Collective, one of the sort of key projects that we're starting with is the RCX’37. So some of you might have seen the RCX’36 that have been designed evolving over the last couple of years. So that was more of a retro, modern sort of retro vibes, bit of modern design, albeit rear motor. So that was my previous version, and sold a lot of those as kits as well. Quite a few of the guys had a bit of fun along with me of racing them. So now the next evolution of that is the RCX’37. So this one's probably more in line with modern design. So not rear motor, so it'll be mid motor. And the layout's very closely based on the current versions and previous versions of the associated B6 and B7 platforms. So that's what I'm kind of going for this concept. So it's a known thing, pretty standard overall. However, we're going to sort of open source it, I guess you could say, which is as many of us as possible to talk about the design, talk about all the aspects of how to bring this car to fruition. As part of that, everyone can sort of play along, so to speak. So for those that like 3D printing, those that like sort of tinkering and designing and building as well, I'm going to make all of the files available. So once you become a member of GP3D, you can download all the files for free. Currently I've got the version 0.1 online, so that's available right now, and which represents what you can see here so far. It's going to evolve obviously a lot more, a few more parts to do, still the uprights and the steering, but the rest of it's pretty close. It's ready to give it a run. So today going to go from this plastic, so that's all printed plastic. The green is the final parts, printed in the PC blend material, and all of the grey stuff in general is just PETG plastic that I've used for prototyping, and we're going to rebuild this into a working prototype rather than a sort of non-functional evolution beta type build, to make sure everything fits and refine the shapes and parts. So we're going to go to something that we can actually take to the track and give it a run. So the goal is to give it a run this Saturday. So it's a few days. Try and get this ready for that, and hope that the weather plays nice. The last few club days have been rained out, so we'll see how we go there. Yeah, so we'll get stuck into it. Going to pull this apart, and then I'll just bring this over. So I've picked up all the first sort of version of carbon pieces from Berserk RC. So as a lot of you know, get all of my carbon parts from Berserk, as a lot of us do. And he's been instrumental, of course, in helping produce the kits that I've been doing for like the Masami cars and Detroit, Losi and Detroit Masami cars over the years, as well as lots of other bits and pieces. But yes, all of these carbon parts will be available, from me and from him directly, as people desire. So these will be the first iteration. You can literally order these from him right now and print out all my parts, which are online, and you can build up yourself a car just like this one. But of course, there's the possibility that the carbon parts will change as well, not just the plastic parts. So there's always that risk that getting these parts done yourselves could be rendered superfluous pretty quickly, depending on what design changes occur. So yes, that's a whole bunch of carbon and FRP parts there. We've got all the sets of arms, a full set of arms all printed. So we'll be putting these on, and you'll see like the rear hubs. I've started mocking up some designs for them. So very much a concept at the moment, but got those as well. Okay, we're going to start pulling all this apart. Probably end up chucking out most of the prototype bits, of course, all plastic stuff, pretty quickly, but it's always good to hang on to a few bits whilst playing around and whilst doing design and evolution of these, because then you can check like iterations of parts and what the previous step was, but pretty quickly I throw them out. For example, I'll keep this bit because got the carbon here, and you might notice it hasn't got a hole in the middle because I messed up one of my models. It was sort of corrupted mesh when I gave it to Simsy. So yeah, it didn't have that hole in it where I needed it. So I'll drill that later for this first test part. That's all the joys of prototyping and designing and creating stuff from scratch, of course. So a lot of the construction of this car is very similar or the same as the RCX’37, for those of you who are familiar with that. Well, pretty much every part's different, slightly different shape, or different details or different hole positions, but quite similar. The main difference, of course, is the motor position. Even the gearbox is, all the same kind of design, same CAD, just rolled forward around the diff axis. Another interesting little design decision here I've gone with so far for this model. The previous models, like the Masami cars and the RCX’36, I used the kick-up carbon, so 30-degree kick-up molded into the carbon plate, and that is super cool. It's how the original Masami cars were, of course, which is where we developed that along with Berserk. And it is quite expensive though, so as cool as it is, it obviously adds a lot of cost to not just the development process, but the final product, final retail value and all of that. So this time I've got a lot of experience now with this plastic material and the printing process and how strong things can be. So going with a flat chassis if it turns out that it's just unviable and breaks, then we'll have to change that plan. But for now, for the development process, going with a flat piece of carbon chassis, and the bulkhead has all of the angles and kick up built into it. So I'm going to go with 25 degrees for this one. Sorry, 22.5 degrees for the bulkhead. And then the arms at the moment are 25 degrees, so an extra 2.5 degrees there. Of course, that can be set to whatever we desire and want to test and decide is works well. Might be a few different options for different conditions, and you can print out different bulkheads accordingly. But for now, yes, I'm going to start with that. So effectively a 25 degree kick up in the arms. So I'm really excited to sort of find out or discover how keen people are for being involved in the sort of design and development process in this Grand Prix 3D membership program. Because I love this sort of stuff, and that's what I've been doing now for quite a while. So definitely keen to find out how much others are interested and want to get involved as well. It would be very, very cool to see the inputs and the knowledge from people to go into this sort of design. But yeah, we'll see what happens. So I printed this chassis as just test piece in 3 pieces. It does actually fit on the bed, I discovered later. But, especially while doing development, printing out the parts. If you just want to make a change to work on the front end, you want to make a change to the front end hole positions, which I did a couple of times. Doing it this way, you only have to print out a small piece, so not as much time to wait for the next evolution. Okay, let's ripple this apart. Let's get this battery out. There's my battery Coyote, not this one, but one of my batteries. I think I use this in the 2-wheel drive car, so not my Coyote 4-wheel drive one. But it's got the sticker on it from the Worlds, and I was running my sort of 89 inspired RCX’37 after doing all of the 89 Masami replicas, and somehow the universe moves in mysterious ways. Apparently it was a coincidence, ended up with number 89 as my race number at the recent Off-Road World Championships in Sydney at Hills. So I like to believe it was a coincidence, and it's super, super cool. Even if it's not true, somebody organised it, then that's still super cool. Carbon top deck, and you can see here we've got the black, got the insert nuts already pre-installed, so they've been pressed in nicely. So I've got some spare ones here which I use for the plastic parts while prototyping. There we go. That's what's that one? So I've got the back cover, same as most of the modern cars. The back cover sort of comes off. We've got the 246 bolts. That comes off with the shock tower, and that lets you access the diff, so you can take the diff out for rebuilding quite easily. And then the 2 halves, left and right halves, can stay in situ. So I'll just strip all this apart. Have sort of printed a later version, so I'll rebuild it with all of these bits, of course. But I'll use all the same bolts pretty much, so we'll strip this apart anyway. Like this guy, looks like a little dinosaur. There we go. Yeah, I've got a sort of more modern C block, D block design for the rear as well, with a lot of spaces front and back that you can use to change the wheelbase. I think I've got about about 5 or 6 1mm spaces, which is like a tuning option. And then I've got a shim, like a shim plate that will sort of shim plate that can go underneath the D block to lift the back of the hinge pin up and down, so you can change your anti-squat. I think I made it at the moment, so 2 1mm shims is the default. That gives you, to check the design, I've forgotten. I think that would give, it's either 0 or 1 degree anti-squat, and then you can go from there. That's all fluid at the moment. The C block here, it's functional, maybe not the prettiest thing in the world, but of course with being printed I do need a reasonable amount of meter there to make sure it's strong enough to hold the front of that arm securely, because that's where it's going to get a lot of force coming back on the arm here. So you can see here there's let's see it better on the bottom. There we go. So you can see it's sort of like a line along there, which is where I've joined these parts. Might be sort of stupid, go without saying, but with the plastic part, printed parts like this, if you do print them in multiple pieces or similar, just super glue them together if need be, just temporarily, just dodgy. I didn't even get it straight, I don't think, but super glued together, while doing the prototyping process. So that's always handy. I might go without saying, so ignore me if that's an obvious thing for you. At the moment, I've used the same 1/8 inch diameter titanium hinge pins, which I got made for the Masami cars, in a range of different lengths to suit that RC10 Masami car. I use them for the RCX’37. For the inner hinge pins, the outer hinge pins, I use the associated ones. Which are 3mm across. So yeah, so I've just used this out of convenience, but to be determined if it's the way to go or not. Might get some 3mm ones made, or might find something that's readily available on the market. It's right length and everything. So it's often the length is the issue. If it's something that's readily made, or an existing product might not be the right length for this design, so then do you design around that and maybe compromise the design a bit to fit something that's available, or get them custom made, which is usually the best solution. Can be a bit more costly up front, but if we can sell not going to be a big volume, but if we can sell a small, decent enough volume, then it becomes a viable thing. Cool. Okay, so cards are one pieces. Stripped it down. So next, we're going to build it. And as I said, there's no instruction manual to follow, so I'm going to make this up as I go. So it'll be a bit of fumbling around. Where should I start? Probably start with the gearbox. Start at the back. I just did a bit of test assembly of a few parts, but it's just a couple of screws, not much. I can't remember which version of the arm this is. I think it's the same, so I might just keep that one as a spare. But it might not be the current design. That's another thing, like keeping track of what versions which parts are. I haven't really got a good system. If you guys out there have ideas or methods of doing that sort of thing, it would be greatly appreciated. I usually just go by just the knowledge of what you've done for each part, but sometimes it can be not obvious, so I'm sure there's a better way to do it. What is this? Is it 10 mil? I've used FRP. This is not carbon, it's fiberglass reinforced plastic for the towers. I know everybody loves carbon because it looks cool. I actually prefer to use FRP for towers due to the material characteristics, which means that they'll have a bit of give in an impact. So they absorb the impact, which does two things. One is carbon will not really absorb an impact, it'll either hold strong and transfer the forces into some other component, or it will snap. So, yeah, in real world, maybe a bit arbitrary. But yeah, I thought, having the give, I guess, or the flex, it absorbs the impact and doesn't transfer it into the plastic part in this case, because that could be prone to breaking. So I'll need to find out if that's a weak point or not in this design. One big aspect of 3D printed parts is, see what focus there, is a bit of post-processing is required. So it's more like plastic modeling. Okay, got a bit of focus. More like plastic modeling in that respect, which is, you need to trim a few edges and sand the bit smooth. I don't know, some people obviously won't like that, but it's all part of the modeling process. So those that like modelling, then that's pretty normal. So just definitely keep in mind, if you're into this sort of stuff, you'll already know, but if not, then be aware that you do need to get the scalpel out and the sandpaper out. Especially with like the gearbox parts as well, I would always spend a bit more time on sanding them, especially the surfaces. So like, sanding the mating surfaces nice and flat always ensures that it all bolts together the best way it can, sort of square and no gaps. I'm thinking previous a version of the RCX’37 gearbox, so I made like a gasket. It's actually a printed gasket using the TPU material, like a flexible, slightly flexible material, and that worked really well, I thought. Sort of takes up the, it's only sort of 0.4, 0.6 millimeters thick, the way I print them. Takes up the gap, sort of, you design the parts to have that extra sort of space in them, so it can accept the gasket and not be, wrong tolerance. But it does take up the imperfections in the plastic and all that sort of stuff, and helps keep the dirt out of the gearbox. So I found that worked really well. Haven't done it on these parts yet, but it's a bit trickier with the split sort of, or the cover that comes off the back. It's not just two halves that can clamp the gasket nicely, so the gasket will have to just be mainly this part and maybe the bottom. So to be determined what I can do there. But so get it up and running first, get some testing done, and evolve the rest of the design a little bit more. And then sort of close to the end, or I guess more of a refinement or final aspect or design aspect would be doing that sort of stuff, if I introduce a gasket or not. The other method is to have little sort of ridges and protrusions to sort of lock the parts together, which is another option as well. Obviously it takes a lot more sort of design and thinking and a bit more intricate, but that's sort of the end result is a nice simple result for building and maintaining. See, some of this printing inside here is a little bit, I mean, it doesn't really matter, but it's a little bit, sort of the overhangs are a bit rough. So I'll probably try and refine that a bit later on in the development evolution. So that's more of a, the whole thing functionally works, and just trying to make it so that it prints a bit nicer. There's always compromises with the 3D printing I do, like the FDM printing. The overhangs are the issue and supports, so I'll be looking in the future, hopefully nearer future than later, but I want to get the printer, multi-material printer, which I haven't actually got yet. So there's lots of them out there and available, varying qualities and success. But I do want to get a multi-material printer capable of, such as the new Core. So I've always just playing around with the Prusa ones, so I don't have any other experience. So apologies for being Prusa biased. I'm not sort of choosing them after having vast experience of different types. I started with it and I've only used that, so I've got absolutely zero experience with other brands. So I mean, it works for me, it does what I need. May or may not be the best at given points in time for doing certain things, but that's what I've got familiar with. But I am keen, hopefully sooner than later, as I said, to get a multi-material. Not so much for the colour. There'll be probably different things I can do with the different colours in general, but the main reason is actually so I can use a different material for the supports. And when you do that, you can use, I'm not sure what it is yet, it might be a PETG, so printing all this sort of stuff in the polycarbonate PC blend for your actual part. Potentially, if I can use PETG as the second material for the supports, that those two materials don't stick together, I think. To be determined, correct me if I'm wrong. But there'll be some other material that just does not stick to polycarbonate. I can use that for a support. So that what that means is then you can have a much closer tolerance, or basically a zero gap tolerance between the support and the component, which means that the actual component lower surfaces can be pressed onto that support more firmly and get and it won't be perfect, it won't be as nice as the sort of top surface, but you get a much nicer, less rough bottom surface or under surface, supported surface, which will just make it, the overall component a bit nicer finish. Won't make any difference to the performance or the strength or the characteristics or anything like that. It's just purely cosmetic. Also, all the sanding and stuff I don't really bother much with. Just do the basics when it's prototyping, in terms of knowing that the parts are going to be short lifespan and never even hit the track in a lot of all the initial development. You just print a part, roughly fit it, tidy it up a fraction just so it fits nicely in the required areas. But yeah, don't worry about doing a really nice sort of sanded finish until it's a part that's maybe going to have a bit more of a lifespan. For the photos, for example. Cool, so that's that. What's this bit look? Oh, that screw's doing there. That's random. It doesn't have a nice fresh bit of carbon. So I've got a channel, what's it called, a recess, designed into the diff area, so the diff can sit as low as possible. That just gives a little bit of clearance. It doesn't need all of that recess, but needs a part of it, so make sure there's clearance there. And I've got a slot here as well, which is more for fun or cosmetics, so you can run your sensor wire down that under the battery. It's quite deep. It's 2.5mm thick carbon I've gone with. The hole is 2mm. So it's just enough, leaves just 0.5mm or less to of material underneath. But yeah, so you could in theory run your motor wires under there as well from the speedy at the front. Maybe not 12 gauge, maybe if you had 13 thin wall or 14, maybe 13 thin wall gauge would probably fit along with your sensor wire. So yeah, you could do super stealth wiring, but probably not essential, but that's part of the design I had in the previous 36 car, so kept it on this one. Okay, so C block. It's 12mm. So C block. So this hole basically accepts the hinge pin. There's a bit of wiggle room there for your anti-squat and the angle and stuff. So I've got 3 degrees built in inboard toe, and then different blocks. Eventually just have different blocks for different toes. The shims at the back does the anti-squat, and we can evolve that sort of design and have different versions. So you just print out different pieces for the setting that you want. The holes, I think I've got the holes pretty close, but just running the 183 in just to make sure they are not loose, but so that the hinge pin, the arm will rotate on the hinge pin, so the hinge pin will be like fixed as such, so it doesn't need to be a loose fit into the blocks. Hopefully that'll work okay. Similar design to previous. Make sure I've got the holes for those hinge pins facing towards the back. At this point, I could bolt this on the wrong way. The gearbox will not fit on if you do that. So. We'll soon find out. Cool. So the gearbox, so basically put in the lay shaft and the idler, kind of half temporarily put that together, and then that will, you can see there's a channel shape there, and that locks in over the C block. So it's a nice locking design. Don't know if it's necessary, but it's keep that section of it nice and rigid. So you can see there it all locks it up without even any bolts in it yet. Bolts through the motor plates. Goes on there. Awesome. So these M3 inserts, it uses the M3 insert hardware piece there. Little black inserts. So they're not nylock, so always put a bit of Loctite. And I also like tighten everything later on once it's one situ. So that's the gearbox with the lay shaft and the idler so far. So now okay, so now this is onto the chassis. What have I got here? All these 10mm. Yep, so there's a bunch of 10mm countersunk for all of the underside. I'm not sure what sort of design solution I'll need to come up with here, but it's as you tighten up those back bolts, it kind of twists because you haven't got much material through the side here. So it might be okay eventually, I'm not sure. But I've tried a couple of different sort of locking pins and they don't really work. So at the moment, that's the way it is until I come up, or anybody else comes up with a solution that can help. So yeah, so I just leave those a little bit loose once the cover's on and all the diff is in, everything, it'll hold it square as you tighten it up. So you just need to leave all the screws just backed off a half turn initially. Okay, got the diff, which probably needs bearings. Drops in. Spins nice and free at the moment. So obviously as part of this design and evolution, also just build once it's all finished, you need to make sure a gearbox spins nice and free, of course, which is critical to good performance. Okay, now the cover on. So we've got the rear camber plate there. Again, I'll just leave these a bit loose. The hole needs to be a bit bigger at the top of this. So I want those bolts to just slide through like that at the top, because they thread into the lower half of the gearbox. So make sure it clamps it down nicely. You want the top to not really offer much resistance. So it's got a little bit still there. Reamer through there. Yes, that's the sort of thing, like to refine it. I'll go back into the CAD and just make the hole in this part a little bit bigger. Let's try once again. Yep, so this top cover has the 6 bolts. So 2 on the side there, 2 at the back, which double as the camber plate, and then 2 at the front to sort of support the top section. So we'll find out if that's overkill or sufficient, because obviously that holds the tower. So I wanted to try and support that piece as much as possible, because it seemed like it's a vulnerable area in terms of strength. So we've definitely got a bit of a gap. I can see that. Very hard to see. Yep, you see a bit of a line there. So that line there is the joint between the top cover and the gearbox lower part. Might be okay actually, but that's the sort of thing where I'd look to slightly refine that tolerance if it needs it, because that's where the dust and stuff will get inside the gearbox. And again, back to the gasket type design or some other design change to minimize, or well, ideally eliminate the dust and dirt getting inside the gearbox. So yeah, have to keep an eye on that. So it looks like there's a bit too much of a gap there from ideal. Cool, so that's all in. So that's your sort of back end gearbox. And we can tighten up some of these other bolts a bit more. And same at the back as well. There's like a gap between the two halves here, which looks quite large. So I definitely need to resolve that. You can almost see inside. I think it compresses a bit further in, but it's definitely a gap there. So that's where I'll probably make the gap a fraction bigger even, and then design a gasket into it. Okay, maybe a T gasket, so I can have the vertical part and then the lower horizontal part that goes between the, where are we? Between the gearbox and the chassis. So that might work. It's a good idea. I'll think about that. Cool. So let's see. How's the gearbox? It feels a bit tight. So that's where I need to work on the tolerances as well. Which is always a tricky one, so as in loosening off the bolts. Oh, that freaked up a bit. Yes, I think it's still getting slightly twisted somewhere as you tighten it up. So I'll need to have a think about that and make sure it's got the support and the locking sort of structure in the right places. Like laterally there's no play there, so I think that's where some of that tightness might be coming from. Okay, I need to widen out the holes for the bearings for the diff. That we'll have to do for now, but definitely a bit of resistance there, so I think I've squashed the diff in a bit too much because the lay shaft and the idler is really good. So it's close, not quite perfect yet. That one's crushing it too. It's runnable, but I'll keep refining that for the next iterations. Not too bad. Just can't crank some of the screws right up super tight. Cool. So I think this is a large one, so 81 spur. So made sure that an 81 could clear the chassis still. So like almost minimum height of the lay shaft. We'll do the front, put the arms on until the later step. Let's do the front. No real science to the order, just tinkering and building. Some of these bolts aren't quite long enough, but they'll have to do for now. Like a sort of sandwich. So you've got the servo mounts, which double as a bit of a base. Sort of sanded these okay, not too bad. Yeah, so it doubles as a bit of a base for the front top deck. So you can see here the top deck on that 22.5 degree angle sits onto these at an angle. And then the side rails, one piece at the moment. Hopefully that's a good design, but the front of the side rails clamps on top of the top deck. So we'll see if I can tip this up. So as that goes on, then the top part clamps it down. And we'll find out if that's all strong and rigid enough. That. So the front bulkhead and the tower. What screws for this? Countersunk. So the rear end. It's 12 mil. 12 mil into the bulkhead. And again, my preference, I got the front tower out of the FRP as well. Similar concept to the old RC10. You know, the towers were the FRP, the famous water green sort of FRP colour. And they've been fantastic. So like running all of these Masami cars and running the RCX’37 with fiberglass towers. So I use basically the same fiberglass as the Masami cars, and just a slightly thicker version. So I think Masami's was 2.5 mil, and we used 3 mil for the 36 car, and that was brilliant. So like no breakages, absorbs the impacts and crashes. So this is 3 mil. So yeah, so it's the same stuff, just black in this case. But there's a cool thing about the services such as Berserk these days, where you can get all these parts done in whatever different materials you like. So when we have this available, which is now from now on, you can request different materials if you want carbon. If it breaks the plastic, then don't come complaining because I warned you. Or you can have different colours, whatever's available, I guess, in materials to some extent. Cool. So this is the one piece, or well, it's one piece bulkhead, of course, but the kind of the kick-up's built into the bulkhead and it just mounts flat to the chassis. So that'll be a key part of the track testing that I'll need to determine if that's viable and strong enough. We'll definitely be crashing it enough to find out, that's for sure. Deliberately crashing for sure, right? To test the robustness. Definitely not lack of skill. Yeah, Yeah, it's nice design. Like I reckon it's simple and elegant. Means the chassis will be a lot cheaper for all of us. The strength and robustness is the key. Although I've recently we've seen on online there's a bunch of breakages on, I think it was the AB74 four-wheel drive off-road, which is snaps sort of, it's alloy chassis of course, and it's been snapping across here where there's some, on that one there was bolt holes really close to the edges, and it created like very little material around that bend in the alloy chassis for them. And yeah, I've seen a number of breakages there with obviously big crashes and impacts and hard landings and stuff with the speed and the forces going through those things these days. But that's always a critical part. Okay, what have I got here? So probably not the right sequence to put this together, but just fits. I do not know what the right way to do this is. What do I need? I think I need a couple of spaces and some of these dodgy bolts that are not right yet. Another big part of the development and producing kits, etc., is when the time comes when it's pretty much finished or close to it, the assembly manuals are critical, key part of it. Very time consuming to do, but very important because people need to know how to assemble it. Otherwise you get in a mess like this trying to work it out. Have to come up with a nice elegant sequence of putting this together. In fact, the little shims on the top, I'm probably going to make them into one piece, so rather than having separate shims under there, it'll just be a single piece of plastic or whatever's required. And then you sort of assemble that through the top deck, do all that first onto the bulkhead probably, and then attach that to the chassis, which tipping will be a lot easier. Let's try it. This is a mess. So I'll take the bulkhead back off the chassis, and then we'll try and do this a better way. So I'll pop that off the servo as well. Okay, which way does this go? So there. 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 Haha. There we go. That isn't kind of the right way to do it. Yeah. These two long bolts here need to be longer, but that's all I got for now. Cool. And I've got a slight gap here deliberately between the sort of front edge of the top deck and the back of the shock tower, because when that does get an impact, it'll push the shock tower back. And I found on I think it was on my Yokomo four-wheel drive, I found if it's nice, beautiful butt joint, it causes like a pinch point or a point of like isolating pinpointing the force, and it would sort of not fully snap the tower, but it cracked the tower and as it bent backwards. And I found if you have a gap and then it's just into the plastic has a bit of give, especially this material, the polycarbonate. has sufficient give for it. Just it's not much, of course, you can't really see it, but it has a bit of give. And then along with the flex of the tower, that all seems to work quite nicely. So it allows it to bend. It doesn't have a sharp edge to cause a pressure point, so it won't snap the tower at that point or crack it. So yeah, so we'll see how that goes for this as well. Okay. A couple of bolts will go on the top as well. We'll do that later. So let's see how this goes onto the chassis. Uh, 240 grit I've found is the best to start and end with, basically, on this polycarbonate material. Yeah, I don't know, just like coarser or finer just doesn't seem to do the job as well. It's really weird. So even to finish it and get a nice sort of smooth, nice kind of finish, the 240 still seems to be the best. Like if you go finer sandpaper, it just doesn't seem to do it, which is strange. Also, tried a couple of a different printing technique here, which is to be determined. But like I say, on this one, I've got like a fuzzy skin texture on the top. I don't think you'll be able to make it out on the camera. You have to see it in person one day. I assume you can't really see it there. And then normal printing, like print these on a slight angle, so it sits the base of it flat on the bed. So the top has a slight 15-degree angle as it prints. So it just gets just the normal finish on this one. But then on this one, got like a fuzzy texture which gives it a nice sort of matte sort of. It's actually a sort of like zigzaggy kind of pattern that the print goes at instead of a straight line. But you get sort of it's very fine, but like a rough texture, but in a very fine way. So it gives you a different sort of finish on it, completely cosmetic, completely irrelevant to performance or strength or anything. Just playing around with that a bit. Still haven't decided if I'd go that way for mine or for the kit parts, but you guys can print it as desired, as you want, and using all your techniques and materials as well. If you do print this, actually, it's as you would have noticed, I highly recommend, and I always use this Prusa PC blend filament. So far, I found it's the best for this sort of thing, for making RC car parts. It's super strong, great layer adhesion. The PC is polycarbonate, so it's fundamentally a polycarbonate material. So it has inherent flex sort of give characteristics. So you can see here, I can bend this, so it's not super stiff, especially thinner sort of thickness of the component. It will bend, so that's why it gives and bends and it doesn't break. When you get stiffer, like thicker parts, like a suspension arm, for example, like that sort of thickness of material, of design, I can't bend this with my fingers. Might be able to twist it a fraction. Might be able to see it, but even that, it's just a very small fraction there I can twist it. But I think that's perfect. That's what you want. So in an impact and just normal racing kind of conditions, you want that just tiny bit of give, not too soft so that it flexes and gives you bad performance, bad handling characteristics. That would be the other extreme, which would not break, but it would not handle very well. So I found this polycarbonate blend, PC blend material, has those sort of characteristics, and the layer adhesion is fantastic as well, so it doesn't sort of crack along the layers. This is a PET-G part, a prototyping part, and this is actually stiffer, like a fraction stiffer. But in racing conditions, that's much more, well, it'll crack or break a lot more easily. So a given impact, this will just break because it's more brittle, being less flexible. Whereas the polycarbonate will just have that bit more give and doesn't break. Obviously, everything breaks at a certain point. But yeah, from all of the experience so far, this has been unbelievable. So, racing a 3D printed RCX’37 in the World Championships and lots of other events. Obviously not fast, but handles it, doesn't break, does the job, which is pretty cool. Just for fun, I'll pop this over quickly. Just show this one. So this is the RCX’37, the sort of predecessor, I guess, or the first one I did like this, which was the idea was it was kind of like a retro mod, so retro cosmetics like RC10 sort of cosmetics. I'll switch over here and get is it a better view? Maybe not. So you've got RC10 cosmetics, rear motor, super cool. Love this thing so much. Awesome fun to drive. Doesn't quite have the rotation and performance of a modern car. It is what it is. But yeah, that was the concept there, which was heaps and heaps of fun. And that was my World Championship car that I raced. So the RCX’36 naming, so RC as in RC10, radio control, from the original RC10. The X is sort of the X factor. Bit of a create my crazy projects. So X factor involved, so that's the RCX part. And then the original, not the original, but the third IFMA World Championships, but the first in Australia. First and only up until a few months ago. So now the first of two off-road World Championships for buggies in Australia was in 1989. And so with the history of that event in Australia, and I've done the 89 Masami replica, and then 2025 now, when we just had the second ever IFMA World Championships in Australia, is 36 years apart. So from 1989 up until 2025 is 36 years. So that was my RCX’36 naming. So that was the concept there. And now this one is the RCX’37. So pretty much the incrementing by one, plus started at the moment, but it'll be released like a final, well, probably never a final version, but a first full version for release, which we'll also do a kit for as well as having all of the files now as part of our GP3D Membership Collective. So the files will be available. We'll have physical parts available, carbon sets available. That'll be in pretty much next year, so early next year, 2026, and that's 37 years since the origin. So that's where we've gone for the naming convention for this. Okay, what have we got? So that's enough about PC Blend and the texture for now. So can you see that there? So that clamps down, so threads into the top part here. So the idea is that will clamp down. Loosen those off a fraction. 2 on 2 bolts on the side here to clamp to the chassis. So these railings, I guess they've got an aspect of stiffness, but I'm going with a pretty stiff, 2.5mm carbon chassis. These, I guess, would add a fraction of stiffness, which you could loosen off these 2 screws if you didn't want it. To be determined if that makes any difference. I don't think it will, but you never know. And then obviously the side, you can put the stick on the Velcro for the body mounting. So just check the other side on. Got a pretty crap print here, if you can see that. Probably not supported it right, or need to do a bit of tweaking. Might not be able to see it's just a bit crappy on the outside under the supported surface again. So I might slow down the printing of that part, or improve the support configuration. The other side printed okay, so not sure why this one didn't. It might just be a slicer refinement I need to do. I like to set the the torque setting on this at the lowest or the second lowest setting, usually depending on the part and the material, but so it starts to slip before you sort of bottom out the thread in this sort of plastic, or any plastic, and then just hand finish it, because you can feel the resistance much better, I find. So always do that. I assume most people do, if you're using a power drill, of course, driver. Yeah, that's something with this plastic as well. I found it behaves the same as injection molded stuff that you get generally, in terms of the threads. So if you're threading into like PLA or PETG materials, which I wouldn't consider an engineering or performance type material, you use it for more prototyping or for static stuff. If you're just doing static displays, static models, PETG is really good, as well as the PLAs and tough PLA, etc. PLA plus, I think. But yeah, they don't actually hold the threads that well, I've found. Happy to be corrected, but they, you can thread a bolt in once, not too bad, but taking it out, putting it back in lots of times, it destroys the threads pretty quickly. But this stuff doesn't, so this behaves the same as any sort of plastic part you would have in RC, I've found, which is brilliant, because that's what we need. Because obviously with these sort of things, you take them apart and put them together a lot for maintenance and building, and as we do. Okay. Yeah, so it's not all, but a good chunk of the front done. Check that out. I've gone for a design here which I used on my retro mod Yokomo 870 as well, which is the plastic bit, so I'll get rid of that. But to strengthen the sort of front hinge point section of the arm, I have designed sort of like a little carbon brace that sort of goes around the hinge pin, and then you just bolt it in with the shock screw and another screw to kind of locate it. And that just adds a bit of support sort of around the hinge pin at the front there, because that's where you get the biggest impacts, of course, in the front corner. So I never really had an issue out at the Knox track where I do most of my vintage racing and don't really call it modern racing, but running this sort of thing in the normal modern club racing. Knox track's very gentle. It's sort of old school dirt, and not a lot to hit at high speed. Not much grip compared to the modern tracks. So you go out to Keilor and other modern tracks, it's a lot more harsh on the cars. So I found when I ran my Yokomo there, I kept killing the front arms, just snapped it through the hinge point where all the force is pinpointed. Yeah, on that race day, I made a temporary makeshift sort of version of this sort of thing using another bit of carbon I had, and it worked really well. So got me through the rest of the day, and now it's being transferred to this. So yeah, so my chief test driver Ushan suggested I do this on this model as well, which I hadn't thought of doing because I didn't have it on my RCX’36 because that was predominantly running it on dirt. Didn't have an issue there, and not four-wheel drive as well, so not quite as much sort of force and speed and violence going through it. But so Ushan suggested I do it for this model, for this RCX’37, which I thought was a great idea. So there it is. So I'll keep that as a spare as well. That. So these are the new ones. I might do a quick trim and sand of these new set of suspension arms I've just freshly printed. I've already done that one, so that one's good. So I might do it for these other three. I'll probably fast forward the video by the time you see it to not bore you. Yeah, so I trimmed off all the rough lower supported edges on the back trailing edge, and then just sanded with that 240 grit paper. Don't have to do this, but makes you feel good, I reckon. And just makes the part look slightly nicer. Just remove those last few little bits of rough edges and corners. While I'm not bad at it, I might just drill this out as well. Drinking problem. now. Got the 1/8 reamer, so I can do the inner hinge pins for now for this. So as I said before, like whether it ends up being 1/8 or 3mm, I'm not sure yet. But for now it's 1/8 for the inner hinge pins. The other ones, probably just use the A ones for now. So I might make it 3mm on the outside just so it's compatible, in case I need to swap backwards and forwards. And before I've honed in on the design there. Where's the hinge pin? Yeah, that's not great. I feel like it's nice and free, but it's not lined up. Like the two ends, the holes are not lined up quite right yet with my printing quality in that one. So that's going to have to be widened out a little bit more than ideal, but fine for testing, of course. Not fine for a final product. That's all part of the design and evolution and prototyping. Cool, that's good now. Awesome. Okay, let's clean up this little mess and then assemble all the arms on. That'll be pretty much it for this video. I think I've got that installed. It'll be a bit more work, of course, to put the shocks and electronics and stuff in, which probably won't do on the video. Unlike this one, and we'll be aiming to test it this weekend. Its first ever run. It's always exciting. Well, it's it can be a bit anticlimactic if something show-stopping goes wrong, like break apart or something doesn't work as expected, or basically break something on the first lap and don't have a spare. Can always be a bit of a letdown, but touch wood, I haven't really had that in all the previous cars that I've designed and prototyped. Like the Masami cars, they both went remarkably well for their first run. So stuff like that is always exciting, especially when it works. Okay, what do you reckon? Let's do the front. That's what we're going to do. We've got the hole. Oh, yep, the hole's good. Excellent. Always love a bit of this sort of stuff. to spray on the moving parts, the suspension pins and pivots. So you can see with this sort of design, so the pin sort of locates that carbon brace at that point. Have a screw in the middle which gets clamped down at the end, and then whatever screw for the shock you're using. So I've got the three, there we go, the 3 holes there. So you just use one of those obviously at a time for wherever you're putting the shock position on the arm. And then that kind of, yes, obviously they've got the strength of the carbon around the hinge pin, and that supports them of the arm in those 2 spots. So it basically gives maximum strength that we can get in that way for that sort of maximum impact point, or the worst impact point. Okay, so that one falls nicely. This one's pretty good. Probably make it a fraction better. It would wear in pretty quick, a couple of laps or a couple of runs. So it's always nice to make sure it's nice and free from the get-go. Not perfect, but pretty damn close. Yeah, a couple of runs, that would be perfectly fine. Anyway, cool. So there's the front arms. So yeah, I've got the hinge pins there, but we don't use any circlips in this design, front or back. That's all sort of captured. So I've got the back of that hinge pin is sort of captured by the leading edge of the chassis there. And then the front will get captured with a few things. So we've got so this bumper is the TPU, so this is not polycarbonate, so it's quite sort of chunky, so it's not that bendy, but can sort of see here, twist a bit more than bends. You can probably see that twisting. So this is like a flexible plastic, so it's not rubber, but it's a very flexible plastic. So I've never tried it, but I'm tipping it's pretty bad. It'll be pretty bad for suspension components and arms, so it'd just be too flexy. Car would just be wallowing and doing weird stuff all over the place. But it's great for bumper bars and sort of things like that where we need you need the flex. So yes, that's the bumper. And then I've got these bits and the camber plate. What else? I've got to use one of these funky bolts for the front. That's all I've got. Got a couple of, where'd they go? Massive long 30mm bolts, which I've lost. Where did I put them? Oh, they're already in here. Stupid. Cool, so they just sort of bolt in from the bottom. They capture this camber plate. So I've got the little insert nuts again, M3 insert nuts there on the bottom. So the ball stud can bolt in from the top. So that goes through kind of like that. So it fits on the front. And then we have a sort of center bolt there. And then the 2 long bolts from the bottom go up through into the M3 insert nuts into the top deck. And that kind of all locks it and clamps it up. Pretty similar to the RCX’37 design, other than the fact that these long bolts don't go through the chassis. yeah, the kick-up chassis in that previous design. So these are way too long. 30mm, so I need 25mm on the top here, I think they were. So they're on the way in the post. I haven't got them yet. So I'll put those almost tight. I'll put this front bolt in. Yeah, so they'll have to stick up for now. Crank that up. Okay, they're tight. Middle one's tight. And then there's that piece I just drilled from earlier, which I've also lost. Oh, there it is. Chucked it on the rubbish pile. Not very clever. Cool, so that's the front brace. Yeah, so a combination of these sort of arm brace pieces, and then the oh, that is an interesting concept. That bolt, I think I changed that design. That's not going to work anymore. Yeah, anyway, so the brace across the front there braces the two hinge pins so that it's, you know, all combined. It's a nice strong structure, because that's where most of the impacts occur, of course. Okay, I'll use that one, which has a big massive hex head on it. I need, what have I got? Some sort of low profile ideally, or even countersink. That might have to become a countersink piece. Oh, no, I remember. That bolt goes in through the plate. Forgot my own design. So there we go. So yeah, so I'll just take that off again. So yeah, you don't put that center bolt in. That plate goes over the hinge pins. So it's kind of like almost floating, just the one bolt in the middle. Kind of got elongated holes there, so it's a bit of play so it doesn't bind everything up. But it's mostly, you know, strengthening it laterally. So then that bolt cool. And then the bumper goes on, so it covers all of that. And then two screws there. And the rear lip of it sort of just goes over the front of the carbon there. I might make that a bit longer. So it sort of like maybe covers those screws as well. Not sure. Might not be necessary. Anyway, so that's a bit. So yeah, that's sort of bumper that doesn't really add any strength. Obviously, just does its function of impacts. What bolts are these? Don't know. Probably the 12mm again. With this flexible TPU material, definitely don't want to over tighten these, because it'll crush it a lot more than now the plastic, solid plastic. So there we go, just lift up so it's flush and no play. Beautiful. Yep, that bolt is definitely needs a different one there. So I'll swap that out when they arrive, and these ones for the shoulder ones. But yeah, otherwise that's front end. So for the testing, I'm gonna going to bolt on the B6.4. So you use 6.3, 6.4, B7, front, all these pieces, all the front uprights. Currently in the process of doing our own plastic versions of the uprights and the knuckles, same as the rear, or as well as the rear. So that's the front steering knuckle so far, just a bit of a test print. Haven't done the upright yet, so definitely be looking for your guys' input if you have design suggestions on how all that can work. I want to make it compatible so you can run either, so hopefully eventually more parts that we do the better. We can have some fun with that, and also you can swap out existing AE parts or potentially others that we can design for. So they will go on. Got the alloy bell cranks as well, so I've probably got the plastic one in here, but alloy one's probably better, but I'm going to go with plastic and maybe a carbon plate or something eventually. So obviously everybody can build with the bits they desire. So these guys are gonna pop onto here. I have a couple little spaces. So drawing 3mm, not the 1/8, because we're going to use the AE parts for now. But yeah, I definitely want to try and do as many of these parts as I can, so they can be bespoke GP3D. And make them made up as desired. Might be a bit more readily to come by and cheaper and stuff if we do it that way. That really just gives a few more options for us all. In hindsight, it's better to do this before you put the arms on the car, which I should know by now. I'm actually I might leave this bit to later. That's all just standard stuff. But yeah, so we'll go straight in. Got your little spacer, the ball stud screws into those M3 nuts, and you put the spacers in. Probably standard on this would be maybe 2 or 3 shims, 2 or 3 1mm shims to space it up, and then that's all that front end's ready to go with the shocks. So let's I'll put that aside, and I will do that another time. Let's get back to this rear end to get the arms on this. Cool. So how do we do this properly? What have we got? We've got shims. Who knows how many? I'll put a couple at the back. And I think I had 6 in total. It was either 5 or 6. We've got a couple at the back. And then 1, 2, 3, 4. 1, 2, 3. Got another one there. What's that? 4 and yeah, so I've got 6mm. So let's chuck 2 at the back and 4 at the front as a random starting point. Also, before I put these arms on, I might pop the shock bolts into the arm so they're ready. Got the so-called D block at the back. That goes on pretty easily. And then we'll chuck a... I'll have to check my CAD what I did again, but we'll chuck one spacer in there for now. Yes, here's the first little prototype of the rear upright that I did. So I've got a plate on the top there which can be swapped out for different plates. Like a sort of carbon, this is the plastic print. I'm going to actually probably run this on the weekend if I can, see if it survives, just to test it. But yeah, ultimately that would be a little carbon plate, and then you could have the hole at different, 1 mil, 1.5, 2 mil, whatever offsets, longer or shorter, or one direction. So you could have maybe 2 or 3 different plates, so middle, +1, +2, and then the +1, +2 you could flip to get it shorter, both shorter and longer from those plates. So yeah, maybe that, and then the usual shims under the ball stud to raise it inside and outside. Yes, that's the idea there. I did another, not that one, did another version which is this one, and line it up. So I got this is all just one piece of plastic, no plate on top. You just screw the ball stud straight in. So see, I've got the 3 holes there, but they're not in a straight line, they're on an angle. So the middle one, sort of middle position, so to speak, and then you've got which way does this go? So I'll put it this way. So it goes like that. Yeah, so middle one, and then you've got like a longer hole here further away, and then a shorter hole here closer in. So you could just mount the ball stud to one of the 3 holes. So it's another idea. Might be a bad idea, might be a good idea, I'm not sure. So then it's just a one-piece print, plus easy to just mess with the holes if you want to change them. I can do different versions with whatever lengths, and then you can have, you just print out the ones that you want to use or want to test. And for those that sort of do CAD or are comfortable modifying the STL files, you can grab the whole vertices and move them around a bit within the STL model, if so desired. But I can do all that sort of stuff in CAD, of course, and produce any number of versions of a piece. Like this is one example. So that's where the sort of open nature and rapid manufacturing of 3D printings can be pretty handy to try different stuff like that. A lot of it might not work. A lot of it might work, and it's up to all of us to play around and have fun and experiment. A lot of the ideas might be crazy and silly, but who cares? It's good fun, and you can always try things. And if you find something you like, then then that's a bonus on the track. Cool. So I reckon we will probably finish up there for this video. So again, yeah, if you want to jump on GP3D and become a member, join up with us. We've got the Members Collective there, so a little joining fee and then a super cheap monthly ongoing. So yeah, it's hardly anything to be a member, and hopefully you can get lots of benefits out of it, like enjoyment of printing stuff that we produce. You get a big discount on our shop for physical items as well as part of your membership. So yeah, so even that by itself pays for itself if you're wanting to buy things from us. And then you've got the Discord server. So yeah, make sure you jump on the Discord server as well. Once you sign up, you'll get a link for it, an invite link that you can use to join. And yeah, we can have lots of chats there. So be posting on there a lot with pictures and details and answers and questions and answers, anything you want to know. Go in and have a chat with us, and be going obviously updating all the progress of projects like this one as well. A lot of good content on there, as well as like early information about products when new files are added. So it'll be every month at least we'll be adding new files to the shop. Some of them are members only, so the general public won't be able to see them. Some of them are available for the general public to buy as well, but as a member you get them all for free. When you check out, you just add them to your cart like a normal product, and when you check out, it'll give you a 100% discount, so they'll all be free to download. And yeah, you can download those as often or as much as you want. Cool. So yeah, thank you for watching. I hope this was an enjoyable video. I'll edit out some of the boring bits. Hopefully you've just seen it in fast motion, or I've got rid of all the boring parts. And yeah, we'll give you an update next time. Might be some more build video on this, especially if there's specific updates as we progress over the weeks and months, and as we test it. So it'll be a lot of sort of track testing evolution, and hopefully this can just keep evolving with the community. So it should be good fun, and then there'll be lots more projects in the future as well. So thank you so much again for watching, and we'll catch you on the next one. Bye.